Hello everyone, my name is Dwi Citra, anak perempuan Segaran, and my metric number is 198839. So in this video, I'm going to do a revision on the from chapter 2, the method of coefficient linear into variable. So here we take a look at the one examples. So we take a look at the example 3. So the question given is solve the x plus y minus 2 dx minus x minus 4y minus 2 dy equal to 0. So here, the first step that we need to do is we need to consider two straight line equation. So from the question given, so we can see the first one, this is one of the straight line equation, and this is inform the another one line equation. So we consider these two. So the first line equation is x plus y minus 2 equal to 0, known as equation 1, and the second one is x minus 4y minus 2 equal to 0. So here we consider these two equation. So this is known as second equation. So we have to determine whether these two equation is intercept or parallel. So if it parallel, so their slope should be the same. So here we can see that both of these straight line are intercept by solving these two, and then we will get the point of intersection. So we solve these two simultaneously. So we can take the first equation minus the second one. So the first minus 2. So we will get here y minus 4y, so plus, so become 5y minus 2 minus 2 is become 0. So we get 5 equal to 0, and then solve, we will get the coordinate of y is 0. Then we substitute y equal to 0 into the first one. So we will get so x plus 0 minus 2 equal to 0. So x equal to 2. So our coordinate is 2 and 0. So here we can see that these two straight line we intercept at the point of 2 and 0. So next we move to the second step, where we use substitution. X equal to u plus the x coordinate and y equal to v plus y coordinate. We substitute the substitution into the original equation. So here we get our x coordinate just now is 2. So we will substitute x equal to u plus 2, and then u plus 2, and then y equal to v plus y, but just now our y is 0, so y equal to v. So we substitute both of these into the original equation. So we will get our x, u plus 2 plus y is v minus 2, then here dx minus our x is u plus 2 minus 4y, our y become v, so 4v minus 2 dy equal to 0. So this 2 minus 2 is become u plus v dx, and then this is minus 2 minus 2 become 0, so we get u minus 4y, here 4v, because we already substitute, dy equal to 0. So here we will get the equation after the substitution. So okay, sorry, I missed to substitute. So we have to do, so dx will become du when we derive it, and then dy will become dv. So we also have to substitute the du and dx and dy here. So we get u plus v dx equal to du minus u minus 4v dy become dv. So here we get the equation after the substitution. So the next step is we need to check the homogeneous of the equation here. So recall back the homogeneous step. So here our MUV will become u plus v is u plus v, and our n UV is minus u minus 4v. So we will check for its their homogeneous. So we will just substitute u with ku and then try to extract out the k and then see the power of k. So here we get ku plus kv equal to, and we can extract out, factor out the k, so u plus v here is the m. So we will get k power of 1 m u v. So here the m is degree of homogeneous degree of 1. So check for the n. So n equal to minus ku plus 4 kv equal to, we extract out the k, so we get minus u minus 4v, and then this one is n, so equal to k power of 1 n uv. So here we show that, it is show that m and n both are homogeneous of degree 1. So after we note that it's homogeneous, so we can proceed with the homogeneous step where we use the substitution. So after we show that both of that they are homogeneous, so we use substitution where we substitute u equal to vw and du equal to v dw plus w dv into the equation just now. So the equation just now is u plus v du minus u minus 4v dv equal to 0. So we substitute u with vw and du with v dw plus w du. So here our u is vw. So we will get vw. We remain the v because we want to leave this equation in the term of v and w. And then our du become v dw plus w dv, and then minus our u is vw minus 4v dv equal to 0. Then we solve this, so we v square w du plus vw square dv plus v square dw plus vw dv, minus here is vw dv plus minus become plus 4v dv. So we solve this. So here we can cancel out vw dv plus minus. So here we can solve, and we can extract out the dw. So v2w and then plus v2 dw plus the dv. We can extract out the dv. So plus 4v dv equal to 0. Then we can extract out v. Here v square plus w plus 1 dw plus b w square plus 4 dv equal to 0, and then we can extract out the vw plus 1 dw plus w square plus 4 dv equal to 0. And then this one, when we move to this side, so it will become 0. So it will leave this equation only. So the equation become v w plus 1 dw plus w square plus 4 dv equal to 0. So we will leave this form of equation, and then the next step is we will proceed with the separation of variable. Since we can separate the equation into the term of v and w, so we proceed with the method of separation of variable. So from this equation, so we separate it into two parts, and then we integrate it. So this we can separate v and w. So we move, okay, so we can w plus 1. We move the w part, okay, we move this side into the this one into the right side first. So minus w square plus 4 dv, and then this one can bring to this side. So w plus 1 over w square plus 4 dw, and then minus 1 over v dv. So see here, we already separate the v and w into two parts, so we can integrate it easily. So we just integrate both sides. So we integrate this side with respect to w plus 1 plus 4 dv, and this side we integrate with respect to v. So noted that here we can the above part is w plus 1, so we can separate the fraction into two parts. So become integration of w over w square plus 4 dw plus integration of 1 over w square plus 4 dw equal to, this side we can integrate it easily, so become negative ln v, and then don't forget the constant, become c. So here we can integrate it separately. So to make it easier, so we integrate one by one. So we integrate it one by one. So first we integrate this part first. So the integration of w over w square plus 4 dw. So noted here we can use the u substitution to integrate this part. So we just let the below part w square plus 4 equal to u, and then the du become 2w dw, and then we want to find this part in term w dw in term of du. So our w dw become 1 over 2 du. So we substitute it and integrate, so it become, here is 1 over 2 integration of 1 over u, w square plus 4 become u, and then w dw become du. So it will become 1 over 2 ln u plus c, and then our u here is w square plus 4, so substitute it, become w square plus 4 plus c. So we done with the integration of this part, so we move to the integration of the other one. So the integration of 1 over w square plus 4 dw. So here, noted that 4 is actually equal to 2 power of 2 plus, so it become 1 over w square plus 2 power of 2. So if we consider here, we can use the trigonometric substitution integration. So we substitute this with the trigonometric properties. So here we use the tangent substitution. So we let w equal to 2 tangent theta, and then our dw become 2 secant square theta d theta. Then we substitute it in this, so it become 1 over w is 2 tangent theta square plus 4, and then our dw become 2 secant square theta d theta. So we simplify it, so it become 4 tangent square theta plus 4 times 2 secant square theta d theta, and then this 4 we can factor out, become 2 secant square theta over 4 tangent square theta plus 1 d theta. So here we will use the the properties of trigonometry, where the secant square theta is equal to tangent square theta plus 1. So we substitute these properties into this. So it will become 2 secant square theta d theta over 4, and tangent square theta plus 1 is equal to secant square theta. So we can simplify it. So it will become 1 over 2. Sorry, here I forget the integration. So here is actually integration. So we get integration of 1 over 2 d theta. So it will become 1 over 2 theta plus c. So we substitute back the theta. So noted that w equal to 2 tangent theta, and then our tangent theta is equal to w over 2. So to find the theta is equal to tangent power of minus 1, so w over 2. So we just substitute the tangent. It's the theta here, so become 1 over 2 tangent minus 1 w over 2 plus c. So here we get the both of the integration, so we just substitute it into this form. So here is the so we just substitute. So the first integration, the integration of w over w square plus 4 dw, so we get 1 over 2 ln w square plus 4 plus 4. Then the second part we get 1 over 2 tangent minus 1 w over 2, and then equal to ln v plus c. So we just move ln v into the left side to make it become to arrange it. So become ln v plus 1 over 2 ln w square plus 4 plus 1 over 2 tangent square tangent minus 1, sorry, and w over 2 equal to c. So here we get the answer after we go through all the integration part. But then it will not be our final answer because noted here that in the first part, here we use two substitution. First is x equal to u plus x coordinate and y equal to v plus y coordinate, and then the second substitution is we use u equal to vw. So to find the final answer is we need to substitute back the value of w, u and v to get the answer in the term of x and y only. So here we substitute back w, so actually from v equal to from u equal to vw, so our w become u over v, and then u is x minus 2 and v equal to y. So here w is equal to u over v, so our u is x minus 2 and our v is y, so actually w is equal to x minus 2 over y. So we substitute back the substitution just now into the answer to get the final answer in the form of x and y only. So our ln v, so our v is y, so it become ln y plus 1 over 2. Ln our w is x minus 2 over y, this is square, plus 4 plus 1 over 2, then tangent minus 1 our w, it is x minus 2 over y x minus 2 over y over 2 here equal to c. So we simplify it, so we get ln y plus 1 over 2, and then here ln of x minus 2 square plus 4y square over y square plus 1 over 2. Here we get tangent minus 1 and x minus 2 over 2y equal to c. So to simplify this, we can multiply each of term with the 2 to make it to arrange it easily. So we time the term with 2, and then this become 2 ln y plus ln x plus 2 square, x minus 2 square plus 4y square over y square plus tangent plus 1 x minus 2 over 2y equal to 2c is constant, so we just write it as constant c. So here the properties of ln 2 ln y is actually ln of y square, so plus ln x minus 2 square plus 4y square over y square plus tangent minus 1 x minus 2 over 2y equal to c. So noted here is ln and ln. So the properties of ln, when ln plus ln is actually the ln of product. So this part will become ln y square times x minus 2 square plus 4y square over y square plus tangent minus 1 x minus 2 over 2y equal to c. So this part we can cancel out, so we will leave the answer is ln x minus 2 square plus 4y square plus tangent minus 1 x minus 2 over 2y equal to c. So now this is our final answer. We leave the answer in the term of x and y. So our final answer is ln of x minus 2 power of 2 plus 4y square plus tangent minus 1 of x minus 2 over 2y equal to c. So here we get the final answer. So that's all from me. Thank you.